Welcome to The Explainer. Sometimes you come across a math problem that just looks, well, impossible at first glance. But what if I told you there was a secret, a kind of magic key that could crack it wide open with surprising ease?
Okay, so this is our puzzle for today. It's called a first-order linear differential equation. But hey, don't worry about the fancy name. What's important is that equations just like this are everywhere, from physics to finance. The real trick is trying to figure out that unknown function y. So, how do we even begin to untangle this?
All right, let's treat this thing less like a dry math lecture and more like a mystery we're going to solve together. Think of it like a locked room, and our job is to find the key to get inside. So you're staring at this, and where do you even start, right? The path forward is not obvious at all. And you can't just integrate each piece one by one to find y, because that pxy term right in the middle, that's the troublemaker. It gums up the works connecting y and its own derivative in this really tricky way. This is where a little bit of creative thinking comes in. Instead of just banging our heads against the hard problem, let's ask a totally different question. What would an easier version of this problem even look like? Yeah, this tangled mess on the left side of the equation, that's really the heart of the problem. That combination of dy, dx, and y is what's stopping us from getting a simple, direct solution. But what if we could transform all that complexity into something really simple? I mean, imagine if the entire left side of our equation just looks like this, the derivative of a single, clean product. If we could make that happen, solving for y would be a piece of cake. We just integrate, the derivative would disappear, and we'd be left with something super easy to solve. And that, right there, that's the billion-dollar question. Is there some kind of mathematical tool, some kind of multiplier that could actually reshape our difficult equation into that perfect, easy-to-solve format? Well, it turns out the answer is a huge yes. The secret, just like our source material says, is all about multiplying the entire equation by a certain function, and that function is our magic key. Its official name is the integrating factor, and its one and only job is to do that one magical thing we were just wishing for. It's designed to perform that perfect transformation. Okay, but what is this function really? Where does it come from? We're not just going to take some formula on faith here, no way. Let's actually build this key ourselves. Let's see how it's forged from the ground up. Our starting point is the skull right here. We're on the hunt for a function, we'll call it v of x, that does this one specific job, turning that messy left side into the perfect, simple form you see on the right. So how do we find this v of x? Well, we can start by expanding the right side of our ideal equation using the product rule, that basic calculus tool. When we apply it, we get this expanded expression, which is going to be crucial for our next step. Now for the cool part. We compare what we started with to what we want. See that? The first part, v of x times dy dx, is already a perfect match. That's great. So for the whole thing to be equal, the second parts have to be identical too. And that leaves us with a brand new, vital clue. This right here, this is the breakthrough moment. That little equation we just found is everything. After we rearrange it just a bit, we get a new, much simpler differential equation. And get this, it doesn't even involve y anymore. It's something we can actually solve to find our magic key, v of x. And when we solve that simpler equation, boom, we get this. This is the formula for our magic key. It might look a little intense, but this elegant formula forged from pure logic is the master key that can unlock any of these problems. Okay, so we've forged the key from pure theory. That's the why. Now let's get practical. How do you actually use this thing? Here's a simple, repeatable method you can use every single time. So here it is, a foolproof 5-step guide. First up, you've got to get your equation into that standard form. Second, find the px term and use our key formula to calculate the integrating factor. Third, multiply the entire equation by that factor. Step 4 is where the magic happens. The left side automatically simplifies. And finally, you just integrate both sides and solve for y. Done. And this is the real power of the method. You can take any messy-looking problem like this, and by just following those 5 steps, you can systematically transform it into a clean, elegant solution. It's a process that just works every single time. In the end, it all comes back to this one central idea from our source material. The most essential part of the whole thing is just finding and using that certain function, our integrating factor, to make the problem simple before you even try to solve it. This whole thing is just a powerful reminder, isn't it?
Sometimes the most complex problems aren't solved by brute force. They're solved by finding the right perspective, the right tool, the right key. It's about making the impossible suddenly possible. And it really makes you wonder, what other challenges could we unlock if we just found the right key?